Welcome to the Vision Break. In this video I will show you how to train image classification models in PyTorch. You see there is 6 main steps. First 3 is about creating a dataset and last 3 is about training the model. I have 2 articles about it. First one is this, creating dataset, and second one is about model training. I will share the links. You can read these two or watch the video, it's up to you. I will share the code, by the way, inside of these articles. So yeah, first we will follow these 3 steps, and I will try to classify fish species. You can see some examples. Okay, I think we can start. Okay, creating the dataset. So I'm not gonna create a dataset from scratch. I will use this one. I found this dataset from Kaggle. I choose it randomly for this video. You see, you can download it like this. Download as zip. But you don't have to stick with this fish dataset. For example, you can go to RoboFlow, Universe, and you can see there's project type. Our task is classification. Click this, and there are hundreds of datasets like gender, skin cancer detection, car colors. Yeah, you can choose any of these and follow the video. Yeah, you can use Kaggle as well for dataset. You see there's a dataset section. Just like RoboFlow, there are like so many datasets. Anyway, I download that fish dataset. You can see the zip file and unzip it. You see the format. Let me first, yes, and delete this. You see the format of this dataset is not that good. There is, for example, 2 times fish dataset. It doesn't make any sense. So I will clean this, and in the end there will be one base folder, and under that there will be 2 more, train and validation. And you see class names, and you can see the image. Let me show you one more class. This is same for validation, by the way. You see. Okay. So there's one script. Let me show you. Yeah, I'm not gonna share this code because for each different dataset you need to process it differently. There's not like one code that works for every dataset because formats are different. For example, this is not a usual format. There's 2 folder, and for example there are masks. So this is not a usual one, so you need to write your own code for different datasets. But sometimes datasets are perfectly formatted, so you don't need to do any process. But basically, I'm gonna show you what I did. There's one base folder, fish datasets, this one, and there's 2 more folder, train and validation. This train and validation, and under these folders, I splitted image with these class names. You see, and you can see like 70% for training, 30% for validation. You can change this value. It is not a rule that it should be 0.7. And in the end, I'm copying image to these folders. You see. Okay, I think we can continue. Okay. Yeah, we have this format: train, validation, class names, and image. For example, this animal1.png, this is a dog image. This is a dog image as well, but this animal3.png, this is a cat image. So this is a very common format. You can follow this. Yeah, you can read this. So now I will explain everything one by one. Yes, I'm in correct file. Yeah, before starting, you can see I have GPU supported PyTorch environment. Actually, let me show you. I will import PyTorch, print torch. Yeah, first I can print version, then I will show you if CUDA is available in my environment. Yes, you can see. But if you don't have GPU supported PyTorch environment, you can directly use Kaggle. Let me show you that. Yeah, for example, you want to train a model for this fish dataset. Go to that page, that dataset page, click this code button, create a notebook. This is completely free, by the way, you don't have to pay anything. Yeah, here you need to just activate GPU. You have three options. For example, I choose this one, and you see that you have 30 hours per week. This is more than enough, and you can see your dataset here. So you can follow this notebook. Like there's different cells. Yeah, it's pretty cool. You can use Kaggle directly. But I already have environment, so let me continue. Okay, here you can see transforms. First we are resizing our image. You can change this value, and we are converting image to tensor, PyTorch tensor. We have two, one for train, other for validation. Yes, you can see. Okay, other step. Yeah, okay, here we are using image folder, and image folder basically, expects this format, so that's why I processed my dataset like this. You will pass directory for train and validation. Let me copy those. Copy paths. Where are you? Yes, here. Yeah, I can delete these. Okay. Validation. Yeah, you can see the directories here and transforms. Let me execute it. Yeah, train data, number of examples, path, transforms. So we will use these two. Okay. We already did that step. Now we will use data loader objects. By the way, I explained, for example, what is data loader or dataset. Like you can read those. Just let me show you. Okay, here we have two data loaders. For one is for train, other is for validation. And here you can see the batch size. Let me execute this. Okay, basically data loader creates batches because training is not done on full training set. It will be done on batches, like 16 example at one time. This is a common rule in deep learning. Anyway, yeah, you can change batch size, by the way. If you have more powerful GPUs, you can set it to 32, 64. By the way, we pass train data and validation data we just created here to data loader objects. Okay, visualizing example image. Yeah, it's always good practice to visualize some examples from your dataset after creating to see if there is any issue. You see, we will only display first batch, so there has to be 16 example if everything went well. You see 16 example. This is our first batch. Let me show you second batch as well. Yeah, you can display validation set as well, nothing changed. Yeah, this is second batch. Okay, we can continue. Yeah, visualizing class distribution. Let me copy this cell. I need to import something. Okay. One more. Yeah, this step is, this is not a step that you have to do, but it is good for visualization of label numbers. Examples. You see, for example, first three class has more example than other classes, but the difference is not that much, so this is not a problem. You can see the same for validation set. You can copy these codes from my blog post. So I'm not gonna explain these lines because nothing important here. Okay, I think dataset part is finished. Let me write some title here, training. Okay, now in second part we will train our models. Let's go. Okay, training model. Now we will follow this last three steps. First we will create function for training the model, then we will create our model, then we will train the model. Okay, creating functions for training models. If you use TensorFlow before, like you used 100% fit function, but there's no function like fit in PyTorch. You need to write your own functions, but there's nothing complex. Let me show you. We don't have device. Wait. Create device object. Yes. Yeah, this is GPU, by the way. So we have two lists. We will append accuracy values to these two lists. Then we have train function. You can see we only process one batch at a time. You can see batch here. Here we are moving image and label to the GPU for faster training. You can see prediction, and based on this prediction value, loss value is calculated. And with backward function, we are computing the gradients. Then step function will update the parameters based on these gradient values. And in the end, we are resetting the gradients because, for example, in batch number 2, the gradients will be changed. So that's why we are resetting all the values. You can see we are adding loss to train loss. This is a variable, integer, actually float, I'm sorry. Then you can see in the end, we are printing training accuracy and training loss. Let me execute this. By the way, we have separate function for validation. Let me copy that. And there is one major differences, and I will show you that. Here you can see model.train. This means that our model is in training mode. So weights will be updated based on gradient values. And here you will see the evaluation. This means so there's not gonna be any update on weights. It will only check if the predictions are correct and print the validation accuracy and validation loss. Okay. Now we will create our model. Yeah, you can read here. For example, this is very long. I'm not gonna explain everything. Let me copy this. Yeah, this is a simple model. Let me add a few more. Okay. You see this is a simple model. Basically, there are convolution layers, railway activation function, then max pool. You can change this filter size. Just be careful the dimensions. You know, for example, we have 64 filter here. So input to the other convolution layer must be 64. You can see, for example, there's 32 filter. And here you can see input is 32 to other convolution. You just need to be careful about dimensions. And here we are flattening the channels, and then we are feeding the values to the fully connected layer. You can see we have 256 neurons. You can increase this value again. We have one more activation function. Then we have dropout layer. It helps to prevent overfitting. It basically randomly drop weights. You can increase this value, or you can add more dropouts to the different parts of your model. And in the end, you can see there's 9. This refers to, let me show you, number of classes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, you see. And here we have forward method. Like, it basically adds outputs on top of each layer, and in the end, you can see it returns the out. So for example, if you want to add more layers here, you need to update here as well. And here we are creating the model and loading our model to GPU. You can see this is a very simple model. Okay, now we will train our models. So we have loss function and optimizer. You can choose any other optimizer. I use stochastic gradient descent here, and you can change learning rate as well. Let me show you other optimizers. For example, Adam, like, yeah, there's so many of them. Okay, I execute it. And now we will train our model. Yeah, you can change this epoch number based on your, depending on your GPU. We have like 32 epoch right now, and for each iteration we will call train and validation functions. We just created them. Let me show you again. Train and validation. You see this one is train, this one is validation. Okay, let me execute this. Okay, training is started, but it will take probably 2 to 3 hours. So after training is finished, I will continue. Okay, now training is finished. Let me show you. Oh, sorry. Where are you? Here. You see done. We have 32 epoch. Let me show you like some accuracy values. You can see training accuracy, training loss, validation accuracy, validation loss, and you can see accuracy values are increasing and loss values are decreasing, and that is what we expect. And this is last epoch. You see we have one more step, I think. Yes, this one. I already copied that. So let me execute this. Okay, you can see red line is training accuracy and other one is validation accuracy. So you can see there is no overfitting, but of course we can train this model for few more epoch, but I'm not gonna do it right now because it is good enough, I think. But of course you can try different combinations. For example, you can increase epoch number, like reduce learning rate for more stable training, or you can add more convolution layers, or you can add more dropout layers for different part of the model. Yeah, so there's limitless number of possibilities that you can try. By the way, it took about 80 minutes. You can see I have an old GPU, but I think overall result is pretty okay. Yeah, we can continue. So here I am saving model. You can see model file here. For example, you can use this model later. You don't have to train it again if you save like this. This is label list. We have 9 labels. Like you can see, these 9 labels. And here I am loading our model. You see, and this is in evaluation mode, so there will be no update on parameters. And there is one test image. Here we are again resizing and converting our image to tensor because that is what our model expects. And here you can see we will print label list, not label list, we will print our label because you can see this is index. We will get label from label list with this index, and in the end we will show it with matplotlib. Yeah, you can see this is predicted label shrimp. Yeah, and this is the test image. I think this is true, but I'm not sure about what is that. I don't have any knowledge about sea animals, but I think it's true. Yeah, anyway, as I said before, you can try different combinations, train different models, and you can use this pipeline for any task, any image classification model with PyTorch. Yeah, I think that's it for this video. Thanks for watching. See you soon.